Welcome to ZY Learning Initiative, an innovative and professional development initiative for integrative learning. This is Muhammad Umair, and in this video we will see descriptive statistics in Excel. Here is the introduction. The descriptive statistics analysis tool generates a report of univariate statistics for data in the input range, providing information about the central tendency and variability of your data. Let's see the descriptive statistics analysis in Excel. Here is the data of student ID and the number of marks gained by these 10 students in a class. We are having different functions, their syntax in Excel like sum, sum. The sum function add values, you can add individual values, cell references or ranges or a mix of all three. For example, equal to sum, double click, then select this data, then enter. So this is 677, that is the total number of marks gained by all 10 students. The next one is count numbers and the syntax is count. The count function counts the number of cells that contain numbers and count numbers within the list of arguments. For this, we would be using equal to count count. This one double click, select the data, then enter. So we have 10 number of observations. Then average. The average returns the arithmetic mean of the arguments. To get the average, equal to AVERA average, this one. Double click, select data, then enter. The next one is median. It returns the median of the given numbers. The median is the number in the middle of a set of numbers. For this, equal to MED, double click, and then select this data, then enter. It is equal to 70. Then mode returns the most frequently occurring or repetitive value in an array or range of data. For this, equal to MODE mod, this one, double click, then select this data, enter. The mod is 55 because it is repetitive. The next one is geometric mean. It returns the geometric mean of an array or range of positive data. For example, you can use geomean to calculate average growth rate given compound interest or other variables with variable rates. For this, equal to geomean, double click, then select this data, then enter. 67.020. The next one is harmonic mean. It returns the harmonic mean of a data set. The harmonic mean is the reciprocal of the arithmetic mean of reciprocals. For this we have equal to HAR. This one our mean. Double click, then selecting data, enter. So this is 66.338. The next one is maximum. It returns the largest value in a set of values. For this we are having this max function equal to max, this one max, double click, and selecting this data. It shows that the maximum value is 82. The next one is minimum. It returns the smallest number in a set of values. For this we are having equal to min, that one, double click, and select this data, enter. So the minimum value is 55. Then range. Range in Excel is the difference between the maximum limit and the minimum limit of the available numbers. So for this, equal to the maximum value minus the minimum value equal to, this is 27. So the difference in between 55 and 82 is 27. The next one is standard deviation. It estimates the standard deviation based on a sample. The standard deviation is a measure of how widely values are dispersed from the average mean. For this, equal to STDEV, this one, double click and then select values, enter. So the standard deviation is 10.056. The next one is variance. It estimates variance based on a sample. What assumes that its arguments are a sample of the population, equal to VAR, this one. Double click, then select data, enter. The variance is 101.122. The next one is kurtosis. It returns the kurtosis of a data set. Kurtosis characterizes the relative peakness or flatness of a distribution compared with the normal distribution. Positive kurtosis indicates a relatively peak distribution, while negative kurtosis indicates a relatively flat distribution. Equal to KURT. Double click, then select data. The kurtosis in this case is minus 1.339. Then skewness, it returns the skewness of a distribution. Skewness characterizes the degree of asymmetry of a distribution around its mean. Positive skewness indicates a distribution with an asymmetric tail extended towards more positive values. Negative skewness indicates a distribution with an asymmetric tail extending toward more negative values. Then equal to SKEW, this one, double click by selecting data, enter. So the skewness is 0.005. The last one is the sum of squares of deviation. It returns the sum of squares of deviations of data points from their sample mean. For this we have equal to DEVHQ. This one, double click and then select data and enter. So the sum of squares of deviation is 910.1. Thanks for watching this video.